Okay, so before the break, we were going over what's going to be our first example, looking at Raptor and Python, how to do things. And during the break, a couple questions showed up. One of those being where to access the recordings. So that seems like a good thing to point out on the record so that everybody can find them in the different places. So on Ivy Learn, there's a couple places to get to them, which we talked about this last week, using Zoom and Google Chrome, like on that stack heap diagram I drew there. Both of those pieces of software will basically ask the computer for that entire heap, everything, every bit of memory it can get. So when they both try to run together, we hit conflicts and things slow down while the computer adjusts it and gives them the amount that it's willing to out of each one. So our recordings will be, they're available on Ivy Learn, and within a couple days, I will also have them posted on YouTube, because the Zoom recordings have different controls for a video than YouTube. And I figure most people are more used to using the controls like we have on YouTube. So I try to get them up there pretty quick. That's also where I just store videos. I use YouTube as just the storage space for anytime I have a video. Videos will fill up a hard drive very, very quickly. Okay, almost loaded. Oh, it looks like it. I see a bunch of dots over there. For people some people had already turned stuff in. A lot of the assignments had already been turned in. There was only one of them. And I try to wait till there's at least 2 to grade. So there's multiple assignments of the same thing to grade before I grade them. And then the discussion boards, I wait till after the due date on those. But that's why I hadn't graded those assignments yet. But it looks like there's at least 2 of several things now. So if you go in our course site, which is much, much quicker when not on the Zoom call, when you're just going to get the recordings from the Zoom call. So there's several places. The first one is down here. There's this link that says Zoom, big blue link. I'll click on that. And I don't have any control over this page. This is a fully automated page. The only thing I can do on this page is add a link to our meeting. So I made a second page that I have control over, but if you go here, there's a tab for cloud recordings. And it will be there as soon as it finishes processing, which usually seems to take about 20 minutes, 20, 30 minutes for a 2-hour lecture. Seems to be about how long it takes. But like I said, I don't have any control over that page. I also put one under modules. If you go to modules, and under resources, which I believe is the very top thing on yours. I have a couple things above it, but I don't think y'all can see the stuff that's above there. But under resources, there's a link for course Zoom room. And this is the one I have control over, so I'll make different notes and stuff. But all the way at the bottom here is where I will put the link to the recording. And the other one, there's Matthew. And the other place to find them, it won't be quite as quick, like that automatic page. It'll be there as soon as Zoom finishes processing it. And I'm usually sitting there watching, waiting for it to happen. So I will copy and paste the link just as quick. But also under modules, I should just use the back button. That might have been quicker. Also under resources is the tab for video lectures. If you go in there, this one, it might take a couple days to get the video there, but it should be there by the weekend every week. All of the videos, all the recordings will be at this playlist. you can just click that link and get to all the recordings there, which is on YouTube, which has the normal video controls we're probably used to using. Zoom kind of hides settings, and Zoom doesn't have as many speeds either. I always try to make it a point to speak slowly and clearly on anything being recorded, so that if you're watching the video, you can hit 1.5 or 2 times speed and get through it a little bit quicker. If you're taking notes, this might still want to pause it and backtrack. Videos are nice for that, or just to review for the weekend or something. But that's the 3 places on Ivy Learn that you'll be able to get the video. So now back to our course stuff. So we'll be doing things in Raptor and in Python. And on the home page, I put this link here on this little general list of notes when I was putting that together this week. The main thing there is we'll be working through a lot of examples in class. We're going to talk about concepts, and then we'll see it in an example. So it can be very useful to follow along that example. So you might want to see if you can find a way to set things up so that you can follow along the examples in class. One that I've seen a lot of people do before, that some people said worked really well, was use their phone for the Zoom call, and that way they're like listening, and they can see it really small on the phone, and then use the keyboard to follow along the example. Or obviously multiple screens work. There's lots of different options, but whatever you come up with, it's a good idea to follow along the examples, or just take notes and then pull the video back up at double speed later and work through the example afterwards. Whatever works best. So instead of using that Python editor in the textbook, I'm going to use a similar online thing where we can type Python, and we'll look at that one in just a moment. We'll start with Raptor, because we're using Python in this class is new just because the textbook we have uses that, so might as well not waste that resource. But this class, everybody that goes to any of the IT programs has to take this class. So it's not just programmers that have to take this class. So really we're studying algorithms and how we set up sets of instructions to give to a computer. And programming is just a nice way to study that because we can immediately see the results. So we'll be using this Raptor flowchart interpreter. Basically, we draw a flowchart, and then the computer will run through that flowchart like it's code. Or we have this generate button where the computer will actually write code in a number of languages from the flowchart we draw. So we don't even have to do the typing the code part. Actually, you could put the flowchart together, generate it in Python. I think Python's on here. No, Python's not on here. But generate it in one of those languages and then run that language separately. We'll look at that in a moment. So flowchart always has these 2 basic parts. The circles, that's our UML standard symbol for a starting point and an ending point. Or an oval, I guess I shouldn't say circle. An oval is our entry and exit points, where we start and where we end at. So we always start with these 2 circles. So that's something that we'll run. I can come up here and hit the, looks like a play button, but we call it a run button. And over here, there's this little slider. This slider controls the speed. So if I turn it way down, hit the run, we can see that start circle highlights, then it flows down the chart to the end circle. Over on our output here, you see it evaluated 2 symbols. Oh yeah, this is how I opened it last time. It might not look like this when you open it. So one thing you might want to do, start with, is come to the tab that says window, or the window in the menu. I guess it's not a tab here, I'm used to ribbons. The window option in the menu has a couple different things. We can tile it vertically so that our output is over to the right-hand side of where we draw the flow chart, or tile it horizontally, which puts the output down at the bottom. You can see there's not a lot of room there, especially if you have it set like with a big font like I do here. Back to the default, it should open up something like that, which you can see the output and the input, and obviously resize those like any window. Graphical user interface, GUI, which we pronounce GUI. We resize those just like any of them. I usually go with the tile vertical, and just that way there's some room over there. You can see that just the start and the end, there were two symbols, so it tells us, well, it ran through it without an error. There was only two symbols, but the most trivial thing. So that's not interesting. We want to do our first example here. And we did that, set up the plan for that before the break, and got all the way to pseudocode, the point halfway between the language we speak and what the computer needs. So now we need to move that pseudocode that was on the board over to the computer thing. The first thing is we need to prompt the user, write something on the screen to tell the user we need a value, and we're going to get a value from the user, input a value. And with Raptor, that was combined into one little box here, the input box. Oh yeah, Raptor will require us to save after so long. So after a certain amount of time, it will automatically pop up that box. So it's a really good idea to go ahead and save it first. I have this folder, you might notice here on the screen, I'm saving this to a folder called delete. It's just a scratch folder, so I'm probably not going to keep this around, as you can tell from the fact that I just mashed the keyboard. This is just an example. So, you know, if this weekend or something, you stop back, contact me at office hours, and we hop back on Zoom and you want to go through the example, well, you might have to make it again, because I'm not going to necessarily keep this one around. But there's our parallelogram for inputs. You just click it and drag it over is one option, and then release the mouse where you want it to go. And highlight it and hit the delete key, or right click on it, and there's options, some different options, one of those being delete, cut, copy, different things. Another option to bring it in is highlight it over here on the left-hand side, and then just click where you want it to be in the flowchart. So you can see my hands, I'm not dragging it this time. I'm just putting my mouse here where it needs to go in the flowchart, and just click, and then it'll put that in there. So you just highlight it over here and then click, or click and drag it over. Either way works. And then to input it, to do something with it, you can just double click on that symbol, and we get this little box here. And I cannot change the font size on this box. So as far as examples, sometimes depending on the screen you're watching it on, that might seem really small, but I don't have any control over that. You'll see there's two parts. Up top, there's a box to enter the prompt. What do we want to throw up? That's what this top part was here. We want to write enter a name so what the user knows what to do. And you always want to be explicit. Never assume that your user knows what to do. Right? Even if you know they're never going to look at those instructions, you always want to make sure and put those instructions there so that they're there if needed. So we want to write something explicitly to tell the user we want a name. So there, where I was running low on space on the board, I just put enter a name. I'm going to change that up some. I'll do a Bugs Bunny input. What's that sound he makes? What's the name, Doc? There we go, the Bugs Bunny input. Some sort of prompt to tell the user, we want a name from you. And there's different ways. In this particular case, yeah, someone in the chat, comment in the chat room about that. Yeah, in this case, I just picked a random thing. A question mark fit at the end. I always like to put either a question mark or a colon at the end of a prompt. That way the user knows there's something expected from them. That's our standard symbol from that. And then that point, it's not going to matter so much in Raptor. When we get to Python, it will. The computer does not know what a space is. If we were writing on paper and a paper says enter name, a human automatically knows to come over just a little bit before they write their name, because the space means something to us, but the computer doesn't know the difference between a question mark and a space. So if we want a space to go between the end of our prompt and what the user types, we need to make sure that is inside of our quote marks. So explicitly put those words on the screen to tell the user we want something. You'll see the second box says enter the variable here. And the user is going to give us something. We're expecting input. So where are we going to store it? We're going to store it in a variable called name. And when we store variables, we have some restrictions. We cannot start with a number or a special character. So things like, there are some special characters we can start with, but that changes language to language, which makes it hard to remember. So for our purposes here, starting out, let's just say always start with a letter. So make sure your variable name always starts with a letter. It has to be one word, so no spaces. But sometimes we might have more than one name, more than one word to descriptively describe our variable. Well, in this case, we only have one variable, so we know what it is. But in very, very soon, we're going to have programs with lots of variables in them. So we want to give them good names, right? We don't want to call them X, Y, and Z. We do that in math class when we're writing on paper because X, Y, and Z are easy to write. I'll put that on the board a lot. And if you're taking notes along, you're going to, when we're writing X, Y, and Z or something like that is very quick. But when we're typing's easy. Don't be lazy with your typing. Spell things out. So even better than name would be like username. So I could write that. But user, and I can't put a space. So couple common methods are to jam the words together. The way I type that there's a capital U for user and a capital N for name. So that way we can tell where each word starts, and they're just jammed together with no space between. That's called Pascal case. Another common one, the one I use most often, is called Camel case, where we would start with a lowercase letter, so a lowercase u, and let the name user, then just jam those words together, and subsequent words start with a capital letter. So a lowercase u, a capital N, and we just spell out username. And that way it's very clear to us what value we're storing there. We see the whole thing. User name.
Now, what did you call that?
Oh, the case? That is Camel case.
Okay.
The one with the capital letter first, that's called Pascal case.
Mm-hmm. I'm sorry, I keep losing my signal.
CAL, and then lowercase letter first is Camel case. I guess the capital letters are supposed to look like the humps in a camel.
Oh, okay.
Another common thing is underscores, which is hold the shift key and thereby the minus, just have an underscore. A lot of people do that because it looks, when a human glances at that, it looks like there's a space in there. And when we see those a lot, we get used to ignoring those. Typically, the standard way to write constants, things that won't change, like our variables or values that will change as we go through our process. But some values we just want to store with a useful name instead of typing that number everywhere, right? Like pi, that's a common one. If we're going to be doing some math stuff, we might want to store the value pi, and we don't want to type 3.14 everywhere. So we can store it to the letters pi. A common way to do that, one of the standard notations, is to do it in all capital letters with underscores. One that I want to point out, because our textbook does this, lots of textbooks like to do this. Our textbook uses a dash in the example. And don't ever use a dash. So many textbooks want to do that, but what does a dash mean? What do we normally use that symbol for?
It's a minus.
Yeah, and that's something the computer knows how to do. So if we use a dash in variable names, when the computer sees that, it's going to look for a variable called user and then try to subtract a variable called name. So our textbook is one of the ones that did that. Lots of them like to do that. So don't do that. Whichever way you prefer. I'll probably use Camel Case most often and just jam the words together. And then we can add numbers, some symbols at the end. You want to be careful not to use a character that means something to the programming language. So for starting out here, let's stick with letters and just numbers at the end. Start with a letter, no spaces, and then add some numbers at the end if you have something like name 1, name 2, or maybe not name, employee number 1, employee number 2, employee number 3, and something to make it meaningful. But we do have those restrictions on our name values. And after we do that, it'll look something like this. I can't control the size of the font here. Right up here is the zoom feature for Raptor. You can zoom way in or way out. I think it goes around here. Something where you can see it easily, and sometimes you might need to zoom way out and look for patterns and stuff. We'll talk about that before too long. But that's how we get input from the user. That's the first 2 lines in our pseudocode. Prompt for the name, and then we store that in a variable. And then output, I'll highlight it here. And just now that we have that value stored, we're ready to output a message. So again, that's the parallelogram, and then Raptor adds those little arrows to help make it clear which one's the input and which one's the output. And once again, we just double click on it. And this time we only have one box. So what do we want to output? And it's just like what I drew up there on the board. We want to output explicitly the word hello, and then plus whatever we stored in that name variable. And I left the space off.
Are we supposed to copy it?
Mm-hmm. So we're going to get the user's name, and then we're going to say hello plus the user. And I think it was you that asked earlier, Zach, about the spaces. So I did explicitly leave it off here because that's one I like to make the mistakes here and show you how to fix them, how to spot them, and how to fix them instead of just making a quick note as we pass. So we're going to get a name, and we'll have the user's name stored, so we don't have to put that in quote marks or anything. It's just whatever's stored there. We do explicitly need to put the word hello beside it.
Should it be hello plus username, since you have it as get username?
Oh, yes, it should. Thank you. And yes, that's an important part. When we start putting it together, things change along the way. That previously, we're just doing one or the other this time. Previously, we would write out pseudocode and do a Raptor flowchart and submit that. And I would always tell people, I can always tell if you did the pseudocode or the flowchart first, because when we move from plan to coding, there's almost always changes. But if we do the code first and then write up the plan as a formality, there's never changes get made. And yeah, so things get changed around. You have to watch for little issues and how to spot it. So I changed the plan and had the wrong variable name there, but now it should run. So I'm going to grab the speed control here, turn it down kind of low, and just kind of run through this. And notice this spot over here on the left-hand side. Let me grab my little pen. Where'd my annotate button go? Oh, so it's going to ask for a name. You can see we got that prompt and then a box for the user to type into. Okay. It prints out that hello message, which has a bit of an error with it, right? The computer doesn't know what a space is. It printed out the word hello, printed out what was stored in the variable username, but the computer doesn't know it needs to put a space there. So that's something to always want to. It takes a minute to get used to remembering to put spaces everywhere. That's one that usually takes people a minute to get used to. So explicitly say hello space plus whatever's stored in that variable. And notice over here on the left, in the that's called a watch window. So all our variables show up there. So as you go through the program, you can see the state as it progresses through the processing. See what's stored in your variables, and this is, you'll want to watch this as you step through the program. Again, we have the speed control, so turn that up and run it a little bit quicker. Type my name in again. Well, that time I got the space in there. Looks a little bit better. It's not really a grammatically correct sentence, but hopefully that's good for the example here. And remember to keep an eye on the watch window. I guess the other button you guys notice that there's more than just a run button. We also have a pause, a stop if something goes wrong and it just gets stuck in the program, just gets stuck at a point it can't escape from. We can hit this kind of escape out of it, or this like step. So we can also just click this to go one block at a time and see what it is at every point. So see it move from the start to that, get the input, step over, we see the prompt, enter the name, it's stored, you can see the right thing stored over here in the watch window, stored in the right place. It's ready to output that. We hit the step button again. So you can see we can move the speed up and down or step through it one block at a time, which is basically line by line through the code and track down problems and things like that. Does anybody have any questions about using Raptor like that?
Can
we
you
got
give
lots
an
of
example? Sorry.
Example of what?
Of like the introducing ourselves for the introduction assignment.
Oh, yes, we're going to do that. So I was
Okay.
going to look at this same thing in Python, and then we're going to come back and look at Raptor one more time with the introduction assignment. And I
Okay,
was
thank you.
expecting to be done with that about 8:10, which will
Okay.
still leave us like 45 minutes of lab time. So yes, then we'll go through that. I just wanted to look at the two languages first off. So there's our input and output, and storing variables, which we will see the variable when we get back to look at the discussion board example. We'll also be using Python, but every one of our programs will use input, outputs, and store things in variables. That's why I like to do that in the discussion board, because it's going to show up in every single program we write. It doesn't have inputs, so it's just, we'll store the variables. So we'll store value, store some data, and then we'll concatenate together outputs and everything. So I like to do that right off the bat. So the other language, our textbook uses the Python programming language, and they have that little editor right in the e-textbook. I have a number of places I can edit Python right here in my computer. I decided to pull up this. So when we write our code, when typing codes, the traditional computer high-level programming languages, that is just a text file. It's a fancy text file. We give it a specific extension so that the computer knows that it's instructions to run and not just text to show. But we typically put those together in what's called integrated development environments, or IDEs, because IT people never say the whole thing. So an IDE is an integrated development environment, and this is one I've been using for a couple years. I put the link here on the homepage. This thing knows a lot of languages. I should give it a second to load so that the browser's not too jumpy. And it's got a lot of the cloud features that make working on the cloud very nice. So I assume most people have used Google Docs at some point before, right? Or Google Slides, where you're working with others on the cloud, and you can work on the same document at the same time.
Yeah.
And
Yeah.
multiple people can work on the same code at the same time. You have chat rooms. So this ID has all that stuff. I've been using it for several years. So that, like, if somebody calls me in the middle of the night with the question about coding, we can jump on here and use the chat room and write the code and address the question right there on that. Multiple people can work at the same time, and it knows a lot of languages. You can see this is kind of a long list of languages, and this is not an exhaustive list. They just started writing things and stopped writing when they ran out of room, starting with the most popular, with some of the most popular ones. And it seems to change around, but there's Python on the list right there. So it knows Python along with C# or Bash, TypeScript, Dart, Clojure, Haskell, lots and lots of languages that it knows. So it's a useful tool. You can use it without setting up an account. Like if you scroll to the bottom of that homepage and click the Python button, it will go to the editor and you can start typing up something in Python to test. I have an account, so I'm gonna go ahead and log in. If you wanna use the chat rooms, you do have to have an account to chat, but it's fairly straightforward to set up an account, or those normal login with Google buttons, so you can just use your Google account with it. It's free, doesn't cost anything. And it's basically a place to type our code. And they call this RIPL. IT people like to pronounce things. So if you're new to studying IT, as you start reading textbooks and things, if a word looks like it could be pronounced, go ahead and try to pronounce it, because we use anagrams and abbreviations all over the place, and then pronounce them if possible. So whoever made this decided that REPL should be pronounced RIPL. I would have gone with repel myself, I think, but we just hit the button for a new one when you're on here, and then choose what language it's going to be in. You can see this list. If I start scrolling, the list goes on for quite a ways. It knows a lot of languages, and a lot of them, when you start something in a new language, there will be tutorials and examples and stuff, so it will help you learn other languages as well. For our purposes, we're just going to be using Python, so we choose one in Python. It'll generate a name unless you want to give it a better name to keep track of it. But this is the one I was going to use for class examples instead of going into the textbook, but it's essentially just like what you have in the textbook. Great. Triple. And once it loads, we'll see a place to type code, and then a console where that code runs at, or shell where that runs at. And coding is really just text files, so this does load fairly quickly. So you can see here with nothing typed in, there's a link to some examples of how, and tutorials for learning Python. So getting started. So we need to do the same thing, just a different syntax. And just like those inputs and outputs were pre-made there in Raptor with pictures, we have a lot of pre-made words that do stuff, some key terms built into the language. That's really what the language is. It's a bunch of keywords that already do things. And in Python, everything about Python is really easy to use. So our thing for input is the word input, but we have to put it somewhere. So we'll need a variable. I'll use the same one. And it's open typed. So with Python, we don't have to say what we have. We don't have to tell the computer we want to store numbers or we want to store words. We just say we want to store something. And then the computer will figure out what type it is. That makes it slower, but computers are pretty fast anymore. Slower is not an issue like it was in 1990, back before most of y'all were probably born. So I'm going to create a variable called a username, and then into it, I'm going to assign something. So that's the equal sign, the assignment operator. So username is going to be assigned an input. And notice that a little bit of predictive text came up. It's running slow. Normally that would come up before A had finished typing that word, but input, and then input does something, so we need parentheses. And what goes inside of those parentheses, we can see from the little prediction there, is a prompt. And there's instructions saying what it is. This is going to read a string from the standard input. And when the user hits enter to create a new line, say they're finished typing or whatever, that last new line is going to be script off. So it tells us exactly what it's doing. Down here it says what it needs. The prompt is a string that will tell the user what we want. What did I do last time? Oh, I just did the Bugs Bunny prompt. I'll do a cheerleader prompt this time. So like, give me a name. Just to change it up a little.
Red Sox.
Something to indicate clearly. Oh, wait, that's cheerleader prompt. We should have some exclamation points there. Yeah, yelling, give me a name. You see just that keyword, the computer knows what to do with. And then the parentheses, to start with here, I'm going to say, we'll describe them a little bit more detail later. We'll say parentheses are our standard symbol that means do something. That's how we can tell input is something to do, whereas username is a variable. No parentheses means store something, and parentheses there means do something. And then in order for what input does, we need that prompt. We need to tell the user what we want from them. Then all the putting that in the storage and all that happens in the background. So at that point, after the user types something, hits enter, we'll have that stored. So variables, creating a variable and grabbing input from a user, very, very easy in Python. Everything about Python is to make it easier on the programmer. And then we'll do the same thing. We want to output that. And we can output it the same way. We have this pre-built thing called print. And print, and then there's a bunch of stuff here. If I type the parentheses again, we should get that little prediction box where it was stuff. There we go. We get those descriptions. Prints values to an output stream. Yeah, that's kind of hard to read. So y'all can see there that sometimes that little description is not going to make much sense. But at this point, go ahead and read those, because that's how programmers write descriptions. So at some point, if you're working with computers, you're going to need to learn how to read the way programmers write descriptions. And it just popped up in the chat room. Do you have to declare username? Not in Python. In Python, we can declare it and use it immediately. So we just say we have it, and if the computer doesn't already know about that variable, it creates it. So the declaration and the usage are combined into one thing. So we'll declare the user, declare it. So we have this thing variable called username. We're going to assign that the input that the user gives us after we show them this prompt, give me a name. And then once we have that, we can print out a custom message. It'll just be the word hello, followed by a space, because the computer doesn't know the difference between space and any other character. And then once again, we can say plus whatever is stored in that username variable. And now that it's on that predictive text there, you're going to hit tab, the tab key, and it will finish typing that. Anybody have any questions about that? That's just the first quick pass at Python. Now when I hit run, it switches to a stop button, so I have that. There's some other tools over here, but they're a little more complicated than just the, I don't think you have things like that in the textbook, so we won't really look at those. Basically, if you hit a problem, just use the stop button and there'll be an error message describing what the problem is. And throughout this semester, we'll talk about some of those error messages that you might see. So we need to enter a name. So I'll come over here, enter my name. hit enter, you get that hello message, hello plus what was stored, plus what the user just gave the program, and then the program finished. We're back to a prompt. Any questions about that? And then the most important part, let's see if I put this over here, this over here, with them right next to each other, do you see what they have in common? That's the biggest thing about doing it in two places. I use a different prompt, and one's in text and one's in pictures, but do you see those commonalities between them? Both of them only take 2 steps.
Yeah.
The start points imply that we have to say what the prompt is, where we're putting the value, and then we can concatenate together multiple strings to make that output. So you'll see there's a lot in common. That's why we look at it in 2 different ways, to study the commonality, because that's the important part. Any questions about the Python there? And then your book has a place to write Python code and run it right there in the textbook, or I put that link there on our homepage to go to this.
So is Python an app we download, or is it on a website?
You can download and install it. It's a programming language is a piece of software. It's not going to have, what it is a piece of software that has keywords built in, like input or print. But you do not have to install it. There's this one on the web page, or there's a Python, a place just like this in the textbook. So if you go to those links in the modules to go to the E version of the textbook, there's a place to write Python code and run Python code right there in the book. But if you want to install it, you can. If you want to install it, it'll just search for Python, and there's a thing that'll say download, and you can just download the latest version of the language, and it will come with a place built in to write and run the code. If you want to do that, simulator, Zach, I'll set you up. But personally, I'm a big fan of cloud stuff, right? If it's on the cloud, we don't ever have to save it or anything. Yeah.
Would you say that the cloud, this program that you're using right now, is more user-friendly for beginners?
Yes.
Okay.
That's why I really like this. There's a lot of really nice things about this one. So this is kind of my preferred editor anymore, especially for simple things or in a class. Because then if you have questions, we can jump on here, use the chat room, and go over stuff, writing the code and chatting and addressing the questions very easily. It's a very user-friendly one, that's for sure. Especially for getting started, because when you install software, like all software, you have to adjust settings, right? And at this point, y'all probably don't know what settings you would want to adjust regarding a programming language. So just using the online cloud-based IDE here, it's REPL, which they pronounce Ripple, IT.com. And there's a link to it right on our Ivy Learn site. So I'm gonna go back over to Raptor, and that assignment that we kind of put off, the introduction discussion board, right? That's a common thing you probably see in all your classes. Well, I always like to do those with if a language is going to be programming, I like to change it up and start by writing a program that introduces you instead of just writing a paragraph about yourself. You're going to make a program that introduces you. There's a couple things we'll need. I'm going to save this earlier one and make a new one. And if you don't save over a certain amount of time, Raptor will interrupt you. So I remembered this time, so I'm going to go ahead and save this as a Discord example. Something like a variable name, right? Something meaningful, no spaces in the names. I'll be able to look at that, tell what it is, just to reinforce that variable naming thing. But if you don't save, Raptor will interrupt you. So 2 things that we will do in every program we write is store data and output and create an output. So that's what we need for a discussion board, right? That's what an introduction is, right? Like for me, there's some data points about me. There's my name, my age, the town I live in. And data points are just a single item, right? It's not a full sentence about me. Right? Like saying my name is Chris is not a data point. There's a data point in that sentence. So we kind of separate them out. And our symbol in Raptor for data point or for a variable, I mentioned it earlier, a place to store a single item. That's the word I was looking for there. My tongue got a little twisted. But a place to store a single item is our rectangle. This represents RAM. We want to store a data point in RAM to work with. The first one, I'll put, I'll just call it name. Set, as we have two boxes, we're going to set this variable called name to some value. And well, it's my name, so I'm going to put my first name there. And then I pointed it out earlier, mentioned it earlier, I'll say it repeatedly just to kind of drill it into your head. No quotation marks means we have a variable, and quotation marks means we have a value, right? About an actual value. So we want to store the value representing my name into this variable, or in your case, your name. But we want to store a value in a variable. So our value, like my actual name here, needs to have quotation marks around it, which I know is really small there. So it shows up bigger after hitting done. The set box is the variable name. And then they have some examples here, right? So set a variable called coins to the number 5. Set a variable called count to whatever was in count plus one more. That's called increment. We'll see that over and over and over. But in our case, we're going to set the variable name to the value Chris, which is a string of characters, which means it needs quote marks. We have to, you think I'm telling the computer, quote me on the fact that my name is Chris, that sort of thing. That might be one way to think about it. So that stores my name into a variable. For the discussion board, it's just store some data points about yourself. Another common data point, I'll bring in another box to store a second data point about myself. Maybe the age. I'm 42 right now. So there's a couple data points about me. A data point is just a single thing, right? That's one little number or word or letter or something to represent me, something about me. It's not the whole picture. So we need quite a few of them in order to do things.
I have a question.
Yes.
How come the number 42 does not have quotation marks?
So that is a great question. I was waiting for somebody to ask that. 40 numbers, computers naturally want to work with numbers. So numbers do not have quotation marks. That way the computer knows it'll do math with them and things like that.
Okay.
Sometimes we would put, when we put them in a string, when we go to print them out, numbers are separate from symbols. Like,
so a number is not a value?
It is still a value, but it's a different type of value.
Okay.
Because if I put that as a string, I said age is equal to, I'll put age string. That way it's not the same thing. If I put quote marks on it, then it's just the symbols for 2. And we can't do math with the symbols for 2, right?
Right.
But the number 42, we can do math with. So if I come down here to the next line and tried to do math with both of those, it said X is equal to 0.5 times age. We can do half of half of a number. No quote marks on numbers and quote marks on symbols.
Okay.
That answer your question?
Yeah.
So like this would run through and do that math. It stored the age as 21. But if I tried to do math with the symbols,
It won't do it.
do a 5 times age string, that's going to be a problem.
I see.
Can't multiply string and 42. Do you see the error message that popped up?
Yep.
Okay. I didn't know if you all would see that error message or not. It changed everything that I could see on the screen when that popped up. So no quotation marks for numbers and variables, and quotation marks for our symbols. And I'm just going to hit the delete key to get rid of that.
Quote marks on symbols.
So now to finish out this, I'll bring that back where you can see that. But to finish this out, I'll just add a third data point in the example. I think the requirement on asks for like, what, 5 data points in 10 sentences? Or was it the other way? There's a requirement in the instructions, but however many data points, just say that many little points about yourself. And it will be okay to refer to yourself in third person to avoid a bunch of pronouns and stuff, because then we want to build up outputs. So then we need to build up some sort of output that uses those variables. So like whatever is stored in the name variable plus the words is plus the word plus whatever is stored in that age variable, and it will turn numbers into strings. So here we can't turn a string into a number and do math with it. We saw that just a second ago. But if we have a number and we try to turn it into a string, like concatenation here, it will know that it can turn numbers into strings. So that it doesn't fail both ways. It is okay to turn a number into a string if we need to do that. So the name variable plus the word is with spaces. It's kind of hard to see there because it's really small font, but I did put quote mark space is space mark space quote mark because the computer doesn't know what those means. Whatever's in the age variable plus space years old, period. Because again, this computer doesn't know which sentence needs to end with a period. So we have to explicitly state every little symbol there. And that's a nice introduction to algorithm, is those spaces and punctuation when we concatenate together output. You can see it a little bit better there. So whatever's stored in that name variable, plus this word with some spaces around it, plus whatever's stored in that age variable, plus the word years old and a period to make that a grammatically correct sentence.
So is that considered one of your 10 sentences?
Yeah, and then that will be one of the 10 sentences. And since one of your variables is probably going to be name, right? Because if the program is introducing you, it's going to say your name every time. It'll be okay to just do them all in third person and just throw that variable in every single sentence, right? So another sentence for this is whatever is stored in that name variable has 3 plus whatever is stored in that pets variable, which should be a complete sentence. So then I'll do plus a period. Actually, I want to throw an error. So I'm going to leave off that plus sign and just put a period there at the end. This is going to hit a problem. So hopefully we'll come back and fix it. Oh, see, it won't even let me hit the done button. I highlighted some stuff in red there, which is really small on the screen, but at the end, after that variable, a quotation mark can't be the next thing. That a string is not. A string is unexpected. The computer's reading through there, and it found a variable that it recognized, and the very next thing was a string, and the computer's like, I don't know what to do if you put a variable next to a string. You need some sort of operation there. The string is unexpected, so it needs an operation, like the concatenation operator or the plus sign. So that variable plus a period to make it grammatically correct. So I'm going to come over here and hit the clear button. Notice down at the bottom of the output, there's a clear button. On Wednesday, I'll show you how to clear it, how to put in the code to clear that automatically. But for now, there's the clear button down there to empty that out. So now if I slow this down, so I can point at things and hit run, it's going to start at the beginning of the flowchart and fill out those variables. You can see it then takes the data stored in variables and concatenates it together into grammatically correct output. Does that make sense? So that's what the first discussion board is. So you'll just want to do that. And since it's a Raptor program, what you'll do afterwards is take a screenshot. If you're not familiar with it, the Windows key, Shift, and letter S will pull up the snipping tool, or the newest version of the snipping tool. And there's a couple versions here, a couple buttons here. This button here will take a picture of the entire window, the entire application. Can you all see the screen?
No.
Yeah, I had a feeling that might not show up. So if you push Windows Shift S, there's 4 buttons up at the top. The one on the left, the far left, allows you to draw a box. So it'll give you, it'll give you little crosshairs. So you can mark like one corner of a box and drag down and mark the other corner of the box, and then it'll fill out and take the picture of like that much of the screen. Or which one was it? Windows Shift S does that on a PC. And then the second button over gives you a freeform one. So you just draw a circle, sort of a weird, whatever shape you want to cut out. The normal Photoshop select one. I think most people in our society have seen that Photoshop select where you get the real fine details in and you can just draw some sort of weird shape you want to take a picture of. In this case, you probably want the box one. Or the third one over will let you take a picture of the entire window at once. And the fourth button there will take the picture of the entire screen, everything on the screen. So Windows Shift S does that on a PC. What all types of computers are y'all using? Anybody got like a Chromebook or a MacBook?
I got a Acer Chromebook and an HP Windows. Okay.
If you're using your Chromebook, which Raptor won't run on a Chromebook, you'd have to be using the remote access thing. It's the search key and the desktop icon, which I guess I'll draw. It's about the middle of the top row. It looks something like that. Control, search, and then the button that looks something like that, a square with a little extra thing at the end. It's choose desktop button is what it is. That takes a screenshot. And if you're on a Mac, Command Shift 3 will take a picture of an entire window, and Command Shift 4 will allow you to select a box to take a picture of. I will write that down on the homepage on iRelearn so that everybody knows that instructions. With like, I'll take a picture or something of what that, what key that is on the Chromebook. It's the desktop key. So if you're used to using Chromebooks, you're probably used to switching between desktops. So the ones that use the different switches between desktops. Control Shift, that button takes a screenshot, and it has all the tools just like Windows Shift S on a PC. So just take a picture of that. The flowchart, which if it gets a little bit long, to make sure it's visible, you might want to need a couple pictures to see the whole thing. or there's the Zoom button. You might still be able to read it from the Zoom. You'll have to try that and take a picture of the output. That way your classmates can see that, and then post the pictures right there on Ivy Learn, which I think I still have open. Yep. There is a button to insert pictures in the discussion board. So after you put together the, what was it, 10 data points in 5 sentences, or the other way? Both the console, the flowchart, and the output.
I think
So
it
we
was
can-
five data
Okay.
points and then 10 sentences. But I
Okay,
think
yeah.
you worded them as 5 assignments.
5 assignments. Oh, yes. 5, because we assign a value to a variable. So five variables, and then put those variables and data points together into different sentences. Right? So one of them is probably going to be your name, because every sentence is it's about you. Every sentence is going to have your name. Something like this. Maybe it doesn't even have to see, you don't even have to necessarily see the whole flow chart, but just a significant section of the flow chart, and then the output. That makes sense, everybody? See what to do on that? And then when you go to post a new one, you'll like hit the reply button. There it is. This button right here is how you upload images. And this button uploads audio and video files if you ever feel like using those in the discussion board, because text gets boring, right? Sometimes it's nice to just add a video. But yeah, just upload those pictures, something that shows the output and at least a significant portion of that input. And that's all. I like to start off with that, because storing data to work with and then outputting some processing results of that data is going to show up in every single thing we do. And that took about 10 minutes longer than I was expecting it to. But that was pretty much what I had on mind for tonight. Does anybody have any questions about that?
I do not.
And then,
You
okay.
answered my question.
Okay, yeah, and then I see a question in the chat room about console or coding part. So try to get both of them. A couple pictures is fine. You can post more than one picture there to the discussion board. But hopefully that makes sense. And to make sure there's plenty of time, I will push the date back. Y'all can see that shouldn't take too long. It might take a couple tries to get used to variable names that don't throw errors, or make sure you get all those spaces and punctuations and adjustments that's debugging. But that'll give you some, the next half hour, we'll call that lab time, is might be enough to at least get a really good start on that. Though I will push the due date on it back a couple of days. And one last thing about those, the programming assignments, you don't need it in the discussion board, but for everything else we program, everything we do in Raptor or any Python assignments, if there's a place to let me know about it, I do ask for what I always call a bug report. Just do a quick couple notes on how programming went for you. So something like this one, the bug report might just be went okay, no problems. Or another bug report might be something like typo in variable name. Fix the typo, ran fine. And it doesn't have to be grammatically correct. You can put it in the submission comments for the assignment, but just, or a separate file, write it up somewhere, and just do a quick reflection on how it went. Let me know what sort of problems you hit along the way and what you did to fix them. And I always call that a bug report. It can be very short. In the submission comments, it doesn't even have to be grammatically correct. Just let me know how developing the program went. Any other question? Any questions? I know I asked a second ago, nobody had questions. So I guess that's it for this evening. There's like 25 minutes left of our scheduled time. I will keep my video set up here. I'm going to stop the recording so that I can get the video posted as quickly as possible. Or I'll have to stop the meeting before Zoom will process the video. So I will stop the meeting, but I keep my video set up here until 8:50. So if you have questions, text messages and IB Learn messages, my phone number's in the syllabus. Those make noise on my phone, and I can jump back on the Zoom call in a couple seconds time to address any questions. But otherwise, that was it for this evening. You all have a great night. Give that discussion board intro a try. I'll push the date back to Saturday. Does everybody think they can get it done by Saturday?
Sounds good.
Yes.
Okay, I'll push the date back to Saturday on that, but still it's best not to wait to the last minute. And the next half hour is probably time to do that. I will be sitting right here and can jump back on in a split second if you have any questions. Y'all have a great night. I'll see you Wednesday.
Thank you. Have a great
Thank
night.
you.
Thanks, Chris.
See ya.